This is number 15 on page 454. For this problem, we're supposed to find the component form and the magnitude, okay? So the component form, if you remember, it's the distance this vector travels in the x direction, comma, the distance it travels in the y direction. So as I go from, in the x direction, -1 to 3, that's 4 spots. And from -1 to 5, that's 6 spots. So the component form of this vector is 4, 6. If you're a formula person, you can take the terminal point minus the initial point. So the terminal point is this one. The initial point is this one. And we call this a terminal because that's where the arrowhead is. Okay? So you can take 3, 5 minus -1, -1. And I always got to say this isn't proper math. You can't subtract a point from a point, but it works for vectors, okay? So if I take 3 minus -1, that's 3 minus -1, we get 4. And then 5 minus -1, you get 6. So you still end up with 4, 6. Second part of this problem is to find the magnitude. Magnitude is the distance from here to here. Well, if you already know this side and this side, you're just going to use Pythagorean's theorem, right, to find the magnitude. So 4 squared plus 6 squared, and then take the square root of that. So 4 squared is 16, plus 6 squared is 36. You end up with 52. Square root of 52 is the same as the square root of 4 times the square root of 13. So the magnitude, and it's usually denoted, what do they call this? Vector V. So the magnitude has these symbols. This means magnitude. Okay, and it's just going to be the square root of x squared plus y squared when you get it into component form. So we've got 2 square roots of 13 as our magnitude for this problem. There's your magnitude. There's your component form.